As we have completed pseudocode and algorithm for binary searching algorithm, let's try to write the Python implementation for that. So inside the searching folder, I'm going to create a new file by the name binary search.py. In this file, I'm going to create a class binary search. Okay, here I'm going to define a function called binary search, and it will take the argument array inside the variable arr and the value that I want to search inside the variable value. Now what exactly we do, we will basically define the ranges, right? Like where exactly we start and where exactly we end. So let me define that variables as min. Min is always starting index, which is nothing but 0 in the array, and max is always the largest index in the array, that is nothing but length of array minus 1. Okay, now along with this min and max variables, I'm going to define one more variable called mid, which is basically used for holding the middle index that we calculate. In the beginning, I'm assigning it with -1. After declaring the mid variable, we will simply run a loop while min is less than or equal to max. That means there are still unprocessed values in the array. In that case, what we will do, we will simply calculate the mid. How we will calculate? Min plus max divided by 2. Okay, but Python can give floating point results, and array doesn't. It is impossible to read the indexes in the array using floating points, right? For that we need to floor it. To get the floor value, we will use the math library here. For that I'm going to import math library. From this math library, math.floor function we will use, and it will basically give the whole numbers so that we can use them for searching. Now what we will do, if the value at this mid index is equal to the value that user has passed, in that case we will simply return mid, indicating that this is a valid position at which the value that user wants to search is available. Okay, otherwise there could be two scenarios, right? Whatever the value that we have in the mid could be the larger than the value that user has passed, or it could be the smaller value than what user has passed, because in here we are assuming that the array is sorted in the ascending order. So what we will do in that else if the value that we have in the mid index, if it is greater than the value that user has passed, that means the mid index value is greater than the value that user wants to search. That means all the left side array will contains the smaller values. So whatever the user wants to search could be available inside the left index. So we need to search in the left part of the array. For that we will simply update the max to mid -1. Otherwise we will simply update the min to mid plus 1, because the value could be available on the right side of the array. So we need to search from the values mid plus 1 index till the very last index we have in the array. For that I'm updating the min to mid plus 1. Okay, now once we complete this while loop, we would have searched each and every possible index inside the array, because the array is sorted in the ascending order. And one more thing that I want to mention is, here we are assuming that whatever the array of values that we are getting are sorted in the ascending order. If the array contains descending order values, you just have to exchange this line number 15 and line number 17 here. So make sure if the array that user has passed has the values in the descending order, make sure you modify the line numbers 15 and 17, you just exchange them. But here a small disclaimer is that we are assuming all the values inside the array are sorted in ascending order. Okay, now once we complete this while loop, right, we would have completed searching each and every possible index inside the array that could contain the value that I want to search. That means there is no index inside the array that is, still needs to be searched. In that case, since the value is not available, I can simply return -1. Okay, this is how we actually implement the binary search programmatically using Python. Now let's try to create a object and call that function and see if it is actually working as per our requirement. For that, I'm going to do binary search bs equal to binary search bs dot binary search, and let's assume that the values that I want to use for searching are 1 2 3 4 5 6 7. Any ascending order sorted array you can pass here, and the value that I want to search is, let's assume that 3 is the value that I want to search. Now what I will do, as part of the first argument I need to pass array, and second argument I need to pass the value, and in the end it will return the index, right? So let's read it inside the variable index, and let's just print that index just so that we can validate it. Okay, what we will do, we will simply run it by running python 3. Inside the searching folder it is available here inside the project. So searching slash binary search.py. okay, if you see the value 3 is available at index 2. That's why we've got the output as 2. Okay, now again let's assume that I want to search the value, let's say minus 20, which is not available inside the array. So ideally we should get minus 1. Okay, minus 1. Okay, so similarly I will leave it to you to implement the binary searching algorithm in which the values are arranged in the descending order. Once again I'm mentioning, all you have to modify is line number 15 should go on to line number 17, and line number 17 should come on to line number 15, because the values are arranged in the descending order. Okay, so this is how we actually implement the binary searching algorithm using Python. Okay, I hope you are also able to implement it along with me. Okay, I'll see you in the next one.